Dear students, now we are going to discuss about multiple integrals. Under these multiple integrals, we will be discussing on how to evaluate double integration and triple integration. As an application of double and triple integration, we will be solving some problem on finding the area of the given region and finding the volume of a given solids. So now, let us start with the double integration. So the basic things that you want to know in double integration are, look at this definition of a double integration. The double integral over the region R of a function f of x comma y is denoted by, so you have to read it like double integral over R, the function f of x comma y into dA, where this dA represents the order of the given integral and which order you are going to perform. So the order could be either dx dy or dy dx. As our function is x and y, with respect to x and y, the order of integration could be dx dy or dy dx. As you see, there are two integrals in the definition. So this integral we call it as an inner integral, and this one we call it as an outer integral. The limits of the inner integral we call it as an inner limits, and the limits of the outer integral we call it as an outer limit. For example, if you are going to perform the order dx dy, it means that if you are going to perform dx dy, it means that inner limit will be for the variable x and the outer limit will be for the variable y. And if you are going to, on the other hand, if you are going to perform dy dx, that means the inner limit will be for the variable y and the outer limit will be for the variable x. Now, the important thing about the limits. There are two types of limits that you can able to see. Either it could be a constant limit or it could be a variable limit. There are two cases that we have in limits. One we call it as a constant limit, another one we call it as a variable limit. If it is a constant limit, that means you are going to integrate over the region of a rectangle. Let us see. First, let us see how to evaluate a constant limit with a simple example. Look at this example. Evaluate integral 1 to 2, integral 0 to 2. The function is x square plus y square, and the order of integration is given as dx dy. So the very important thing before you integrate is look at the order. In which order you are going to integrate. So now the order is given as dx dy. That means you are going to perform first integration for x and followed by y. Now let us see how to classify whether it is a constant limit integration or the variable limit integration. So look at this integral. So there are two integrals here. Look at the limits of the inner integral first. The limits of the inner integral are 0, 2, 0 to 2. It means that it is a constant. It shows that it is a constant term. Look at the outer limit. The outer limit varies from 1 to 2. Again, it is a constant. If your two integral limits are represented by a constant number, that means the given integral falls on constant limit problem. Let us see how to evaluate this one. If it is a constant limit, then you have to adhere with the given order. There is no change in the order, right? What is the order given? You have to perform on the same thing. Let us see how to integrate this function. So what is the function given to you? X square plus y square. And which order we are going to follow? Dx dy, right? Now, let us see how to integrate the term. So, when you are integrating with respect to x, so you have to treat the variable y as a constant term. So like how we did in partial derivative. So when you are differentiating with respect to x, we keep the term y as a constant, right? The similar way we do the same thing in the similar way we do it in integration. So when you are integrating with respect to x, keep your variable y as a constant term. So what is the integral of x dx? It will be x power 2 by 2. How we get this term? Followed by the formula. So what is the formula that we are having? So integral of x power n dx will be x power n plus 1 over n plus 1. Using this formula, what is the integral of x power 2? Here the value of, what is the integral of x power 2? So here the value of n will be 2. So if I put here n as 2, it will be 2 plus 1 over 2 plus 1. So it will be x power 3 over 3. As I told you before, the y will be a constant term. What is the integral of a constant 5 dx? It will be 5x. What is the integral of constant 6 dx? It will be 6x. Similarly, what is the integral of y square? It will be y square x. Now we need to apply the limit. So what is the limit given to you? 0 to 2. So you know how to apply the limit, right? So first we need to apply the upper limit. So what is the upper limit given to you? It's 2. For the variable x, you are going to apply the upper limit. So that means 2 power 3 over 3 plus 2 times of y power 2. This is your upper limit. And the rule is minus, now the lower limit. What is the lower limit? 0. So now you are going to apply for x as 0. So this will be 0 power 3 over 3 plus 0 times of y square. So 0 multiply anything is 0 and 0 over 3 is 0. So the total lower limit will get 0. So you can cancel the term. What is the value of 2 power 3? It is nothing but 8. So you have 8 over 3 and then 2 times of y power 2. Now this function we are going to integrate with respect to y. So now as you did for x, we are going to perform for y. So what is the integral of a constant? Integral of 5 dx will be 5x. So what is the integral of 8 over 3 for y? It will be 8 over 3 y. So what is the integral of y power 2? Y power 3 over 3. So now the limit is 1 to 2. So as before, you are going to apply the upper limit for your y as 2 and the lower limit as 1. So the terms will be 8 multiplied with 2 over 3, 2 times of 2 power 3 over 3, minus 8 times of the lower limit is 1 and here 2 1 power 3 over 3. So on simplification, you will be finding the result as 22 over 3. So this is the result of the given integral. So I hope this explanation would be clear to you. Just give me your comments and then later on we will look on to the remaining problems. Thank you.